Good morning. So yesterday I kind of pumped you guys all up for the launch of the SpaceX Falcon 9, and I know it didn't happen yesterday, but hopefully some of you tuned into Discovery Channel as I suggested at 2 o'clock to kind of get some background about this groundbreaking new technology. I'm just going to spend a couple of minutes talking about it because I think it's important and I learned a lot. So this space launch, which by the way will happen, but now it will happen Saturday at 3:22, and you can still catch it on Discovery Channel or stream it live from Discovery Go. And I'm sure many of the news stations will also show the launch as well. But it is still happening. So when they say a mission is scrubbed, if you were watching prior to that announcement, that means it's delayed, it's canceled, or it's delayed for the time being. And the reason this particular mission got delayed had to do with the weather. And if you watch some of the footage, they kept showing weather maps, and what they were concerned about was different cells that were forming, tornado, thunderstorm cells. They were even under a tornado watch at one point. And even though the weather started to clear, about 45 minutes before launch, they gave the go for launch, and they even started to fuel the SpaceX Falcon 9 rocket. The weather seemed to be clearing. However, there was one cell that they were still watching, hoping would break up, and it didn't. And the biggest concern wasn't so much the weather as they launched and took off into space or out of Earth's orbit. It was more if they had to abort. So with this new rocket, there was a new feature which was amazing. So the two astronauts actually are in the top part, which looked like a space capsule, and that's called the Dragon. And that's where they are. And if something goes wrong, either on the launch pad or after launch, there's an abort system. There's actually a handle that they can pull, and that top part of the capsule will separate. And then parachutes will come out, and they'll land in the Atlantic Ocean, and there'll be people waiting, usually the Coast Guard, people waiting there to bring them back ashore. Well, what they were concerned about with the weather being the way it was, that if there had to be some type of emergency abort, where that top part of the rocket, that Dragon capsule, had to separate and land in the ocean, that because of the conditions, it would not be clear where those astronauts landed. It would be very difficult to see where along the East Coast that they were, and that they might not be retrieved in a safe enough time to save them. So ultimately, that's what resulted in the decision just a few minutes prior to launch. And both NASA and the SpaceX team make that decision together. So they do this little process where they say go, no go, go, no go. And in the end, it determined to be a no-go. So the reason why the time is Saturday at 3:22 is because they have to launch, they call it an instantaneous launch, which means they can't say, oh, we'll postpone it for an hour, or postpone it for 3 hours. They have to launch at a very specific time in order to connect and dock to the International Space Station. So they have to kind of know where the space station is in orbit around Earth in order to launch that rocket at the precise time so it can dock with the space station. If Saturday ends up being a no-go because of weather or any kind of malfunction during the testing phase leading up, there'll be one more chance on Sunday, and then it would be postponed until sometime later in June. So fingers crossed that it happens Saturday. Fingers crossed that you tune in Saturday at 3:22 to hopefully watch the launch. But remember, it's more important for the safety of these astronauts to launch on a day when the weather is clear rather than to put their lives at risk. We've talked about the space shuttle program. We've talked about the Apollo program. We've talked about disasters in the space shuttle program. That's the last thing we want. That rocket itself is amazing technology. It definitely looks futuristic. It brings us into this 21st century. It is a multi-stage rocket. It's a 2-stage rocket. which means after launch, the Falcon 9 itself detaches from the Dragon capsule in the tank. And what's super cool about this, and this hasn't happened before, is a lot of times when you have those multi-stage rockets, it lands in the ocean and it can be retrieved. This time it lands on either like a runway or a runway on a boat. So it actually lands back and can be used again, which is huge for the history of space travel. Absolutely huge, because now they don't have to wait so long to kind of like start from scratch and rebuild. They can refurbish these rockets and reuse them again. So it detaches, it inverts itself, and it flies itself back to a landing pad either on a boat or on Cape Canaveral to be reused. And then the Dragon capsule and the tank keep going, and then eventually that tank will detach as well. So pretty cool technology. Those space suits were wild. And one thing I learned from watching the pre-launch information was that it's all one piece. They're all zipped into one piece, even the helmet's attached. And the other cool thing is parts of the ship and parts of that suit, the space helmet itself, were created by 3D printers. So when you talk about cutting edge technology, it doesn't get more cutting edge than this. And it's historic because this is the first mission where U.S. astronauts are going to launch from a U.S. designed and built rocket from U.S. soil since 2011. Up until this point, between 2011 and present day, we've been relying on Russian astronauts or cosmonauts to take us to the space station. So now we're putting it back in the United States' hands, which is pretty cool. So this is pretty historic in every way. So I do hope you tune in. I know it gets disappointing when you get all excited and pumped up, but this is just more time to get excited, maybe do a little research about it in the meantime. Also, we are going to continue our discussion on the circulatory system. After yesterday's assignment, I realized we're still having trouble with the heart, and I get it. It is very difficult. There's a lot of information to learn, a lot of different parts to the heart and their different functions. And I know this isn't the ideal way to learn, but I'm going to give you some helpful hints and just go over the information. So if you have trouble, you hopefully will get some of your questions cleared up. As always, you can call me on my cell phone. You can Google message me and we can chat there. After we review the heart, we're going to talk about the other two structures, which are the blood vessels and the blood. And then I have some cool videos about the blood in your body today that you're going to watch. So again, when we talk about the most important structure or main structure in the circulatory system, that is going to be our heart. Our heart is going to be responsible for pumping blood between the heart and lungs every day, about 1,000 times a day. And it does this through muscle contractions and relaxations, because remember, the heart is a muscle. It's our hardest working muscle, working 24 hours a day, 7 days a week. So let's go over the parts one more time. So again, we have this color-coded diagram, blue representing oxygen poor and red representing oxygen rich. The oxygen poor side is the right side of your heart. So this is inside my body. The oxygen rich side is the left side of the heart. That's why it's in red. On each side of the heart, we have these two chambers at the top. Those are called atria, or left atrium, right atrium. The atria are collectors of blood. So if you see something that says this collects blood, or this is a collector of blood, it's the atrium. How do you know what kind of blood it collects? It depends on the side of the heart. Oxygen poor, right. So right atrium collects oxygen poor blood. Oxygen rich, so left atrium collects oxygen rich blood. You have two other chambers, the ventricles. And the ventricles are the pumpers of blood. So there's your key word, the pumping of the blood. How do you know where it's going to pump the blood to? Well, it depends if it's oxygen rich or poor. This is oxygen poor blood. It's got to get oxygen. So it pumps it to the lungs. That's where it's going to pick up that oxygen. This is oxygen rich. So the left ventricle is going to pump it to the body's cells to give our cells what it needs. Okay? 2 arteries. There's more than 2, but the 2 arteries that are going to then carry, so carrying is the key word, the blood to either the body or the lungs are going to be your aorta, which is the main artery in our entire body, and the pulmonary artery. Since the pulmonary artery is in blue, that means it's carrying the oxygen poor blood, so it's delivering it to the lungs to pick up oxygen. Here's where it connects to the lungs. The aorta, since it's red, carries the oxygen-rich blood to our body's cells. So when we talk about parts of the heart, the atrium, collectors of blood. The ventricle, pumpers of blood. And the arteries, carriers of blood, carrying it away from the heart to either collect oxygen from the lungs or deliver oxygen-rich blood to the body. So hopefully that helps a little bit. I definitely think the more you go over it, the better you'll get at it. Again, in class, it'd be so much easier because we'd be reinforcing this every day. So you need to take that initiative and you need to reinforce it every day. Watch these videos again. Take that little online quiz I gave you yesterday. Don't worry, it didn't count as a quiz grade. But reinforce it for yourself. Make flashcards for yourself. I'll probably even put a Quizlet up sometime on Friday with Friday's optional fun assignment that will help you review it again. Just to, keep your learning going. Okay? So the other structures we need to talk about are our blood and our blood vessels. And the videos today you're going to concentrate on is going to concentrate on your blood. So let's talk about the job of the blood. The heart is the main structure, but what's the heart pumping? It's pumping blood, right? And our body needs it. Why does our body need it? Because what does the blood do? Well, it's going to transport oxygen to our body cells. It's also going to get rid of carbon dioxide. So that's important. And that's considered a waste product. It helps regulate our body temperature, and it also helps transport nutrients that our bodies need. So it's transporting things our body needs, nutrients, oxygen. It's helping regulate our body temperature, and it's getting rid of what our body doesn't, the carbon dioxide. Your blood has 4 different parts to it: red blood cells, white blood cells, platelets, and plasma. Let's talk about what each part of the blood does. So the red blood cells contains hemoglobin. And the hemoglobin, is what carries the oxygen that your body's cells need. Also removes the carbon dioxide. This is when the oxygen poor blood gets sent into the lungs, into the alveoli, and then you exhale that carbon dioxide out of your body. So the red blood cells are going to be carrying the oxygen our body needs and getting rid of the carbon dioxide that our body doesn't. And what's kind of interesting is that these red blood cells are kind of regenerated every 120 days. So it's almost like you get new red blood cells every 120 days. And where is it made? It's made inside your bones, inside the bone marrow. So now we're starting to see connection between skeletal system and circulatory system. The red blood cells our body needs is made inside the bone marrow. If you remember from skeletal system, you have the hard part of the bone, the outside of the bone, which is the compact bone. And then if you cracked it open, you'd have an area called spongy bone, and they call it that because it looks like a sponge because it's got all kinds of pores. And inside there is the bone marrow. And it's the bone marrow that makes the red blood cells that carry our oxygen and get rid of our carbon dioxide. And every 120 days, it's regenerated. Kind of cool. We also have white blood cells in our blood. These are the fighters. I know I look tough. You can tell I'm not tough, right? I don't know how to throw a punch. They help fight off viruses and bacteria. So here's a connection between the circulatory system and the immune system, right? Because the immune system helps fight off viruses and bacteria. This is also made in the bone marrow. So there's a connection with the skeletal system. We're starting to see some interactions here. Then you have your plasma. And your plasma is the liquid portion of your blood. It's made up of 95% water. It also contains things like electrolytes, proteins, glucose, hormones, all contained within there. And we also have platelets. And platelets are what help your blood clot. So if you get a cut, you don't bleed forever, okay? The platelets help clot up that blood. There are some people that don't have that ability to do that, and they have to take medicine to help their blood clot. If we talk about the composition, our blood is about 44% red blood cells, 1% white blood cells, and 55% plasma. So that's kind of cool. There's 5 liters of blood in your body. So if you think of a water bottle or a soda bottle, 5 of them, that's how many liters you have. If you were to donate blood, you'd be giving half a liter every time you donate. But again, keep in mind, every 120 days, you're getting new red blood cells being regenerated in the bone marrow, which is kind of neat. So blood is one of the other structures. So we have heart, main structure, blood, which is being pumped between the heart and the lungs and to the body and the other organs about 1,000 times a day. But then you also have blood vessels. We'll spend a little less time on this, but there are 3 main blood vessels you need to know about: arteries, veins, and capillaries. We already talked a little bit about arteries because we talked about the aorta and the pulmonary artery. Aorta, the main artery in your body. So the arteries are blood vessels that move blood away from the heart into the rest of your body. So if we talk about the aorta, okay, the aorta takes the oxygen-rich blood and moves it to your body cells. If we talk about the pulmonary artery, it takes the oxygen-poor blood and moves it to the lungs where it can pick up oxygen. So arteries take blood and move them away from the heart to different parts of the body. Then you have veins. And veins are blood vessels that carry blood back to the heart. Okay, so arteries taking it away from the heart, and veins are carrying blood to the heart. Capillaries are small blood vessels that connect arteries and veins. It's kind of like the exchange between the two of them, like a pathway between the two. So arteries carry blood away from the heart to the body, and veins carry blood back to the heart, and capillaries connect the two. And that's all you really have to know at this point for those particular structures. So again, please watch this video. I encourage you to do some research about the SpaceX Falcon 9 since you have some more time to do so if you haven't had a chance yet. There was a great, wonderful special that I stood up Tuesday night, 10 to 12 to watch. I did put it out in the Google announcement, but it was called The Countdown to Launch. You can probably find that on Discovery Channel. And it talks about the history of the SpaceX program. And it shows you the design of the rocket, design of the spacesuits. It goes over the staging of the rocket. It goes over how it's reusable, the abort system, and future plans to go to the moon and then to Mars. So history in the making. Tune in Saturday at 3:22. You know I'm going to be driving you nuts reminding you. You know it's coming. Have a great day. As always, this will be another beautiful day, so get outside and enjoy. Thanks.